implicit partial derivatives in just 5 seconds. So yeah, I'm literally going to do that in this video. And also after I do that, I will explain everything, the tools that I've used from very basics. So just stick with me till the end. I do hope that you will learn a lot. Okay, now let's go with demonstration. So the answer of this one is this partial g by partial x is, my time starts now. 6xyz plus 3 to the power xz divided by 3x square y plus 3 to the power x plus 3 ln y. That's the answer. Like was it 5 seconds? I don't know. Okay, and the answer for the next one. I think this time I need to think of it because I had already planned for the answer. Okay, now this one, this is supposed to be, if I differentiate with, also I forgot the negative sign over here. There will be negative sign, and then after that I will have 3x squared z plus 3z by y divided by, over here I will have 3x square y plus 3 to the power x plus 3 ln y. Though it wasn't really 5 seconds, but you do agree that it was pretty fast, right? So yeah, let us see how I was able to do it this fast. Now for this one, first of all, you need to know the multi-variable chain rule. And also, I don't know if you know or not about the implicit functions. I will explain all of that, but first of all, let us go to the multi-variable chain rule, and then we will discuss everything slowly. Okay, so first of all, also let me start with the single variable chain rule. You might have learned that if y is equals to, let's say, f of x, and again x is, let's say, g of u, in that case, dy by du can be written as dy by dx times dx by du, right? And like this is almost the same as dx being cancelled out, which makes it dy by du, right? Now in the case, let's say, where we had y as function of x and y, and those functions, both x and y, were, let's say, function of t, right? In this case, we do know that, like, let's say there's some change in y dy. The change in y dy will be caused by the change in f due to the change in x, and change in f due to change in y, right? So we write them separately. The rate of partial change of f with respect to x times change in x. This is the change in the function caused by change in x, and the change in the function caused by change in y. So this sum basically gives us the dy. And now if I want to differentiate dy by with respect to dt, it's just same like dividing everything by t, and we get our expression, right? Now, like, this is not rigorous proof, but this is good for analogy or the idea. Now the multi-variable chain rule works in the same manner even if there are many variables. Yeah, and if, let's say, all of these are function of t. Yeah, if these are function of more than 2 variables, again, for that I do have my video where I've explained those things. It's just the previous video, you can check that in my channel. Now we know that if I want to differentiate with respect to t, this will just be df by dx times, partial f by partial x times dx by dt plus partial f by partial y times dy by dt plus partial f by partial z times dz by dt, right? We are going to use this things or the formulas, so that we will be able to later on derive, or let's say do these calculations using some special formulas that we are going to derive in this video. Now what are implicit functions? So most of the time we know that, let's say, y is equals to x square plus 3x. So y is separated from x, right? In that case, if we are differentiating this will just be easy thing, right? We can just differentiate both sides, the second side with respect to x, and since both of these variables are x, so this will be easy to do it, right? Now what if the y is not separated? What if the y is not alone? Let's say if you have xy plus x square y is equals y square is equals to 0, and we need to find dy by dx. One of the ways could be, so to make a quadratic equation, let's say if we make a quadratic equation in the variable of y, let's say by dividing both sides by x square. So y square plus 1 by xy is equals to 0. Now its quadratic formula to solve for y in terms of x, right? Minus b plus minus square root of b square minus 4ac divided by 2a. So now you get a y in terms of x, and then now you can differentiate using rules of differentiation. That's also an approach. But like in such cases where they are mixed, we call these functions as like implicit like functions, right? Because these are mixed. And now for this one, if you are differentiating, what we do is we try to differentiate both sides with respect to x, and now we again use the product rule over here. Now if x is differentiated, that's 1, y will not be. Now y will be differentiated, right? Again over here, x square is differentiated, that's 2x, y square will not be. Now y square will be. Now if we have, let's say, dy square by dx, how we do that is we use chain rule. We make it dy square by dy times dy by dx. So this will be 2y times dy by dx, right? So we use chain rule for this one. So we get 2y times dy by dx is equals to 0. Like now we just like arrange the terms with dy by dx, and this becomes x plus x square 2y is equals to minus y minus 2x square y. So dy by dx becomes minus of 2xy square plus y divided by x plus 2x square y. So we definitely get the answer, but this was too long, right? This was too complicated. Now, yes, so to simplify this very problem, we will make some new formulas. Now, how will we do that? Okay, now notice that over here, this xy plus x square y square, this was is equals to, we have this, right, of this function. Now notice that over here we do know that y is a function of x, right? And so that's why we were trying to find dy by dx, because if it wasn't, then like there was like if there was no relation, then it would not be even a point to find the rate of 1 with respect to other. Okay, now how we will try to find this one now is we'll try to say that this is basically a function of x and y, right? We will now say that we will basically try to say that this entire thing is function of x and y. Let's say even if the expression was like 3xy is equals to 5x square plus 6y plus 70 to the power xy. If this was the case, we will bring everything to one side, right? And we will say that this expression is our function of x and y, a multivariable function. We will first do that thing. Now after that, now of this function, let us try to find the derivative with respect to x. Okay, now over here, let me also tell you something different. Over here, if we had, let's say, y as f of x and y, and let's say if it was x is equals to just x and y is equals to f of x. Now in this case, our dy instead of dt, because these are functions of x now, so our dy by dx would have been partial f by partial x times dx by dx plus partial f by partial y times dy by dx. Notice that over here, in place of dt, there's dx, because both of these things are now functions of x, not t, right? So dy by dx would just have been partial f by partial x plus partial f by partial y times dy by dx. I guess you saw that, right? Yeah. Oh. Wait. This is not y. This is function. I'm sorry. This is the function of the derivative. I'm sorry, guys. This is the function. We basically, this should have been g, not y. so that I would have, because this was y, I wrote over here y, but if this is z, I could basically write z over here. I was trying to do that, and I messed it all up. Okay, I'm sorry, like you might have ran into some confusion due to me, but yeah, I think now it's all fine. So yeah, we will try to use this thing. Now over here, let's say we say that g. Now we have g as this function, which is again equals to 0, right? So if I want to find like dg by dx, that will just be partial f, this function, by partial x times dx by dx plus partial f by partial y times dy by dx, right? This just goes to 1. Now since we know that g is just 0, the derivative of 0 with respect to x is just 0, right? And now this is partial f by partial x, yeah, and this partial f is of this function, and plus partial f by partial y times dy by dx. Now I can take it to other side, and then minus partial f by partial y times dy by dx, yeah, is equals to plus partial f by partial x. So we get dy by dx is equals to negative of, this is the derivative function with respect to x divided by partial derivative of function with respect to y. I can also write this as basically just f sub x. So this is minus f sub x by f sub y. So we saw that this derivative can actually be found in an easier way using the partial derivatives. And I hope that you guys know about partial derivatives, right? Because if you don't know about that, then this wouldn't make sense. Now partial derivative is basically, if let's say if I take a partial derivative of function with respect to x, then we just like say all the y's, we just assume all the y's as constant, and then take the derivative with respect to x. So let's see how this formula works. Now for this case where we found using difficult approach, let's try to find over here. So in this case, xy plus x square y square is equals to 0. Our partial derivative with respect to x will just be, since y is constant and x is a variable, the derivative of x will be 1 and constant will be as it is. Now y square will be as it is since it's a constant, and derivative of x square is 2x, right? For f of y, and now for f of y, x is a constant, so derivative of y is 1 x plus, now again x square is constant, so 2y times x square. Now to find dy by dx, to find dy by dx, this will just be minus fx by fy, which is minus of y plus 2xy square divided by x plus 2x square y. So we see that we have got the same thing, and this actually works, and this was actually like pretty simpler than the previous one, right? Now let's try to see how to find these partial derivatives. So let's say we have such expressions like this, 3x square yz plus 3 to the power gx plus 3 ln y g is equals to 0, right? We know that over here basically g will be a function of x and y. We assume that, so that we can find, because if it's not a function, then we wouldn't try to find, right? Since it's a function of x and y, we will try to find these two things, right? Now for that what we can try to do is, first of all, if we are trying to find a partial derivative of g with respect to x, in that case we can assume y as constant, right? And while trying to find the other, we will assume x as constant, right? Yeah. Now let's try to see. Now again we will do the same thing. We will basically take everything to the one side and make it a function of x, y, z, and let's say call it u, or let's say call it w, right? Now if I try to find the derivative of the w, okay, so let's say if I try to find the partial derivative of w with respect to x, let's say, in that case, what will we have? We will have basically, first of all, let's try to find the formula. We will have the partial derivative of x with respect to x times dx by dx plus partial derivative of f with respect to y times dy by dx plus partial derivative of f with respect to g times dz by dx, right? Again, over here, over here, can I really, over here, is it a complete derivative? No, 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 because g is a function of both the variables. I cannot really write a complete derivative over here. I'm sorry for that, guys. Okay, I think I should write over here partial. Okay, now you know that since w is just 0, this will just be 0, right? Now this is partial f by partial x times, this will just be 1, right? And now this is partial f by partial y. Since we know that y is just a constant in this case while taking derivative with respect to x, this will just go to 0. So now this is again a partial f by partial z times partial g by partial x, right? Now after this I can take this expression to other side, so we will have minus partial f. I can basically write this in like easier way, which is minus fx is equals to f g times partial g by partial x, and this will now be partial g by partial x is equals to minus, like, partial derivative of function with respect to x divided by partial derivative of function with respect to g, right? Now in a similar fashion we can derive another formula which is for partial g by partial y, which will now be minus fy by fg. Like, notice that in all of the formulas the lower variable comes over here in numerator and the variable of numerator comes over here in denominator, right? So that's the case in every formula, and that's how I found these answers. So let me show you. So to find partial g by partial x, what you can do is find minus f sub x by f sub g, where f sub x is just partial derivative function with respect to z, right? And minus, now if I take partial derivative with respect to x, this will just be 6x times yz, because y is a constant. Now this will 3 to the power xz plus, since there's no x, these are just constants, so that will be 0 divided by, now since there's just 1z, derivative will be 1 and the constant will remain, so 3x square y. And similar is the case over there, similar is the case at last, right? Similarly, this will just be minus fy by fz, which will be minus of 3x square z plus 3z by y, because derivative of ln y is 1 by y, z as it is, divided by, and the same thing over here, this same thing over here, 3x square y plus 3 to the power x plus 3 ln y. So this is how we do it, right? I don't really think like my explanation was that good. And like I've noticed that, like, if like the more the topics are there, like in this one there are implicit derivative, partial derivative, multi-variable chain rule, like the more the things are involved, the less like easier it is to explain everything, right? Because these things are the product of like doing calculus for a lot of time, right? And like to just explain everything like in just like a few minutes so that you will understand everything, I'm feeling that that really gets a lot hard. Anyways anyways now once you have this, maybe you can start like searching on your own and learning on your own, and yeah, that's how you do it. Hope this video was helpful. thanks for watching, and look forward to seeing you in the upcoming videos too. And like, if you found this idea helpful, do share with your friends. But I don't know if you even found it helpful. Okay, that's it, guys. Like, goodbye.